So here are a couple examples of trig functions, taking the derivative of trig functions, also involving pi as a coefficient. So let's say we have sine of 2 pi x squared. And notice the squared is on the x. If they wanted it on the sine, they would put it right after the word sine. So sometimes I include some parentheses, so just to make sure I know this x squared is not affecting the sign. So we are going to have to use chain rule on this. We have an outside of sine, an inside of 2 pi x squared. So we'll need to know the derivative of the outside, and we'll also need to know the derivative of the inside. So I'm going to say the outside is sine u, and the inside u is equal to 2 pi x squared. So the derivative of the outside, derivative of sine, is just cosine. Derivative of the inside is the regular power rule. So pi is just a coefficient. It's not going to affect much. It's just going to hang around for the problem. So we bring down this power and multiply it 2 times 2 pi, and then 2 minus 1 is 1. So simplifying that, and most of the time you don't write it out in quite so much detail. Most of the time we just skip straight from here to here. But just so you can see where we got all these numbers. So then the chain rule says you do the derivative of the outside evaluated at the inside. So cosine evaluated at this inside 2 pi x squared times the derivative of the inside, so times 4 pi x. But with trig functions, usually if we're multiplying by anything, we put it in front. So we just rearrange it and put 4 pi x cosine of 2 pi x squared. So there's one example. Next, let's say we have x squared tangent of pi x over pi. So again, pi is a coefficient. When you're over pi, we don't have to do product rule and quotient rule because this is just a coefficient. So if it helps, you can also write this as 1 over pi x squared times tangent pi x. Either way, the 1 over pi, or the pi on the bottom, isn't going to do much. It's just a coefficient. So what we do have here is a variable x squared times another variable function, tangent pi x. So we are going to have to do product rule. So our first function is x squared. I'm going to call x squared a. So we will need the derivative of that. Derivative of x squared is 2x. If you're writing it this way, you could say a is 1 over pi x squared, and then a prime would just be 2 over pi x. Again, it doesn't matter which way because the pi is not going to really affect anything. Right now I'm ignoring it. Basically, I'm just going to include over pi in the answer on this first one. So tangent pi x, I'm going to call that b. We have tangent of pi x, just to separate the two different versions. So tangent of pi x is going to be a chain rule. So in the last example, I wrote it in more detail. This time I'm going to just talk our way through it. So chain rule says derivative of the outside. The derivative of tangent is secant squared. So if you have a hard time remembering that, you do get a page of notes on the final, so write it out. There's also a little kind of trick to remembering it. If you're on a test and you need to try and get one of your answers from your neighbor, you'd be like, "Psst, what's the answer? What's the derivative?" So we have the SST, which is going to represent secant x, tangent x. So the derivative of secant is secant times tangent. It's these other two. The derivative of tangent is secant times secant, or secant squared. So that's a little trick to memorizing it if you don't want to have to look at a reference sheet all the time. So the derivative of tangent is secant squared. That's derivative of the outside. We evaluate at the inside, so we still have pi x here, times the derivative of the inside. Derivative of pi times x is like any coefficient times x. Derivative of like 3x is just 3. Derivative of pi x is just pi. So derivative of pi x is pi, so this is really times pi. But again, we rewrite it and put the pi in front just because we're working with a trig function. So now we need to apply the product rule. Product rule says derivative of the second times the first, so pi secant squared pi x times x squared plus derivative of the first times the second. Derivative of the first is 2x, the second is tangent pi x. Again, the only thing we would need to do to simplify is this x squared should go in front of the trig function. And if we have a pi involved, usually we put the pi in front of the x squared, but the x squared in front of the secant squared. So pi x squared secant squared pi x plus 2x tangent pi x all over pi. You didn't have to worry about that pi on the bottom at all because it's a coefficient, so it will just remain there. So you could solve it the second way as well, having it written like this. I think in the course it ends up with pi on the denominator of everything anyway, so it's probably better to do it the first way, but just to show you a second option. So one last problem, cosecant of pi over x. Again, this is chain rule. So to apply chain rule though, inside we have this divide by x. So what I'm going to do is rewrite this as pi times x to the negative first. That is easier for us to take the derivative of. So derivative of the outside evaluated at the inside times the derivative of the inside. Again, you can write it out in more detail. You could say, well, my outside function is cosecant u, and my inside function is pi x to the negative 1. So derivative of cosecant is negative cosecant cotangent. Negative cosecant times cotangent. Again, you can just use a reference sheet. You don't have to have it memorized. That same rule applies, so the SST, except you would have cosecant, cotangent, and usually we make the negative one, or yeah, the middle, the negative one. So derivative of cosecant is negative cosecant times cotangent. So we just used the associated secant, kind of goes with cosecant. Tangent goes with cotangent. So you put those same ones, but with the cosecant and cotangent. So there's our derivative of cosecant. Derivative of the inside is a power rule. -1 times pi is negative pi. -1 minus 1 is -2. So now we put it all together. Derivative of the outside is that negative cosecant. I'm going to leave a blank space for the u because we've got to evaluate at the inside. So negative cosecant cotangent. So evaluated at the inside is going to happen at 2 spots on this one. We have u and u with the cosecant and with the cotangent. So both of them. And then when they write the final answer, we changed it to x to the -1 in order to take the derivative, but originally this was just pi over x. So we're going to change it back to pi over x because that's how they're going to write the answer. So derivative of the outside was the cosecant cotangent, evaluated at the inside was the pi over x, times the derivative of the inside, so times negative pi. Again, they're probably not going to write it x to the -2. We don't usually like negative exponents. So this rewritten would be negative pi over x squared. You have to move that to the bottom of the fraction to make the exponent positive. So times negative pi over x squared. So you can rewrite this, and we have a negative times this negative in front. So really this is all positive now. So positive pi over x squared, cosecant of pi over x, times cotangent of pi over x. They may possibly just put everything over x squared. I'm not exactly sure which way they would write this. You could say pi cosine of pi x, cotangent of pi over x, all over x squared. And those two things would be both considered correct. So hopefully that answers all your questions. Please let me know if I missed any kinds of examples that you're still having trouble with.